Certainly. Here's an expanded explanation of tropical cyclones. Formation and development. 1. Initial disturbance. Tropical cyclones often begin as a tropical disturbance, which can be triggered by various factors, such as an area of low pressure or convergence zones. These disturbances might start as easterly waves or low-pressure systems and become more organized if the environmental conditions are conducive. 2. Warm ocean waters. The necessary heat and moisture come from the ocean surface. As water vapor rises, it cools and condenses at higher altitudes, releasing latent heat. This release of heat further warms the surrounding air, causing it to rise more vigorously and reduce surface pressure even more. 3. Rising air and latent heat. As the air rises, it cools and the water vapor condenses into droplets, forming clouds. The process of condensation releases heat, which reduces the air density, causing the air to rise faster. This feedback loop creates a strong vertical column of rising air. 4. Low pressure and rotation. The Coriolis effect causes the system to spin. In the northern hemisphere, this rotation is counterclockwise around a low-pressure center, while in the southern hemisphere, it is clockwise. The rotation creates a cyclonic circulation that organizes the storm and strengthens the pressure gradient. 5. Development conditions. In addition to warm water, low wind shear is crucial for development. High vertical wind shear can disrupt the cyclone's structure, causing it to lose organization. The cyclone also needs a moist environment to sustain its growth. Structure. 1. Eye. The eye is a relatively calm and clear area in the center of the cyclone, where the pressure is at its lowest. The size of the eye can vary, and its clarity depends on the storm's intensity. The eye's formation is a result of the surrounding strong winds pushing air inward and downward. 2. Eye wall. The eye wall is a dense ring of thunderstorms surrounding the eye. It contains the highest wind speeds and most intense weather. The eye wall's strength and structure significantly impact the cyclone's overall intensity and its potential for causing damage. 3. Rain bands. These are spiral formations of clouds and thunderstorms that extend outward from the cyclone's center. Rain bands can produce heavy rain, squalls, and tornadoes. They are responsible for much of the cyclone's precipitation and contribute to the storm's overall moisture distribution. Intensity and classification. 1. Intensity measurement. The intensity of a cyclone is primarily measured by wind speed and central pressure. The Saffir-Simpson hurricane wind scale provides a way to classify cyclones into categories based on wind speeds and the potential for damage. Lower central pressure generally correlates with higher wind speeds and a more intense storm. Central pressure. The central pressure of a cyclone can drop significantly as it intensifies. A lower central pressure indicates a more intense cyclone, as it reflects the depth of the low-pressure center. Cyclones with very low central pressure are usually the most destructive. Movement and tracking. 1. Steering mechanisms. Tropical cyclones are steered by prevailing large-scale wind patterns, including trade winds and mid-latitude westerlies. The movement can be influenced by the position of high-pressure systems, which can either steer the cyclone or block its path, causing it to stall or change direction. 2. Track changes. Cyclones can experience shifts in their track due to interactions with other weather systems, such as high-pressure ridges or troughs. These interactions can alter the cyclone's path, speed, and intensity, making accurate forecasting and tracking essential. Dissipation. 1. Weakening factors. When a cyclone moves over cooler waters, it loses its primary energy source. The lack of warm, moist air prevents further development. Land interaction causes friction and disrupts the cyclone's structure, leading to a reduction in wind speeds and rainfall. High wind shear can also cause the cyclone to weaken by disrupting its vertical structure. 2. Land interaction. Upon landfall, the cyclone's energy source is significantly reduced and the storm undergoes rapid weakening. The friction with the land surface and the lack of moisture lead to a gradual loss of strength. The cyclone typically dissipates over land, although it may continue to produce heavy rainfall and winds for some time. Additional factors. 1. Cyclone stages. Tropical depression. The initial stage with organized convection and a defined area of low pressure, but with winds less than 39 miles per hour. Tropical storm. A more organized system with winds between 39 to 73 miles per hour. It begins to develop a more defined structure. Hurricane, cyclone, typhoon. Once winds exceed 74 miles per hour, the system is classified as a hurricane in the Atlantic and Eastern Pacific, a cyclone in the South Pacific and Indian Ocean, or a typhoon in the Western Pacific. Burr 2. Cyclone interaction. Interaction with other storms. Cyclones can interact with other cyclones, leading to phenomena like Fujiwara effect, where two cyclones can rotate around each other. This interaction can influence their paths and intensities. Understanding these detailed aspects of tropical cyclones enhances forecasting capabilities, helps in managing responses to their impacts, and aids in the protection of lives and property.